Hey Kim, I wanted to talk to you about types of chemical reactions and like how to identify them. So this is actually super easy to tell. Um, all you have to really do is just kind of like with on this assignment, all you have to do is look at like the patterns that you see in all of your types of chemical reactions. Okay, so for example, our first type of reaction here in Model 1, you can see that it usually starts with two things and ends up with one at the end. This is called a synthesis reaction. Okay, so our first type is a synthesis reaction. This is where you have two things on the reactant side, and you go to having only one thing on the product side. Okay. For our second one, on here we have decomposition. I'll change colors here. And hopefully you can kind of you can draw a conclusion, like similarities between these two words in understanding that synthesis usually means make something. Whereas decomposition, you think of things breaking down, or at least hopefully you do. So if you understand that these two are kind of like the opposites of each other, hopefully you can see or understand, especially when you're going through your assignment and you get to Model 2. You can see that we have chemical reactions that start as one thing and end up as two things. Okay? This would be decomposition. It's the opposite of synthesis, where we start with one thing on the reactant side and end up with two or more products. Okay? We're going to switch back over here to brown and look at the next type. So we can see on here that we talked about synthesis, we talked about decomp. Then it has our third type, which is called single replacement. Okay, single replacement. And you see the word single, hopefully you should understand that is one thing getting replaced. And this one is also fairly easy to understand and is self-evident or self-explanatory. If we look at Model 3, if we look at our equations, we notice that we have three things, the three elements, but we have two things here, okay? But we also have two things on the other side. But we need to see which one is by itself on each side. On our reactant side, the lone one is zinc, whereas on the product side, the lone one is iron. Over on the reactant side, iron was with chlorine, but on the product side now zinc is with chlorine. So you'll notice that iron got kicked out. So this is what a single replacement is when one thing is switched around in your between your reactants and your products. So we have the same number of reactants as products. Okay. We have the same number of reactants and products, but the parts are switched. Normally we only have one thing. This is why it's called single. Thing is switched. So for example, I'm going to put down in here the FeCl3. I'm going to put that reaction here. Okay, so the thing that was by itself kicks the thing that was like so basically zinc and iron switch places. Okay, so that's what single replacement is. Then I'm going to do our last type of reaction here, which is called a double replacement. And from the word double, double of course means two things. So two things are replaced in this one or switched. Okay. So I'm going to look at model 4. And I'm going to write down one of these here equations. So we have AgNO3. We have silver nitrate, I believe. And we're going to add sodium chloride to that. Sodium chloride. And then on the other side of the equation, we see that it now says silver chloride plus plus sodium nitrate. Okay. Notice on your reactant side, we have 2 separate things and 4 total elements. So that is something that a double replacement should have. It should have 2 separate compounds and at least 4 like pieces to it, whether it's 4 different elements or like a polyatomic and 3 other elements, or like the polyatomic takes up a space. So there should be 4 things. Okay, and notice in this one, our partner for silver here was nitrate before, but now it's chlorine. So basically our basically silver is with sodium's partner, and sodium is with silver's partner. Okay. So both of those, so 2 things switch places in this instead of just 1 thing. Okay. So with this one, we should have uh, 2 compounds and 4 so we should have a total of 2 compounds and 4 elements or parts on both sides. And then 2 parts switch partners. Okay, that's all a double replacement is. Okay, so that's that one. Then I'm going to go to our last type of reaction. Now, I don't know if you got this far, but you'd notice on your pre-knowledge that you don't have a 5th type here, but your assignment says you do, which is model 5. With this one, type number 5 is called a combustion reaction. Okay. Now, combustion is actually really easy to understand, but you'll notice a lot of them look like double replacements, where they have 2 things, or they either look like double or single replacements. You'll notice that you have 2 things here. You have 3 separate elements, and you end up with 2 on this side. And it, but there's a problem here. When you go over here, there isn't a clear explanation as to how things switch places. But here's a nice thing to know. If you look at what we end with on each of these, notice it is all CO2 and water. CO2, water. CO2, water. Combustion is a reaction that ends up with us getting carbon dioxide and water out of it. Okay, both of those are, CO2 is a gas and it usually has water vapor. So combustion, because combustion is, burning. What do you get when you burn something, when you have a fire? The fire looks like it's smoking. That's usually carbon dioxide, but you also get water out of it too. So combustion reactions always end with CO2 and water as products. Okay? So combustion kind of throws you for a loop. Instead of you going, oh, what partners do you switch from reactant to product? Now it's asking you simply, what do you end with? If it's this, it's combustion. No other reaction ends with CO2 and water except combustion. So whenever you see this in the product side on after the arrow, it doesn't matter what is here in the front, as long as it is CO2 and water, you have combustion. Okay? So those are the 5 types and how you distinguish them. Let's go back over that real quick here. Combustion ends with CO2 and water. Double replacement is where 2 things are replaced or switch. So these 2 things, they should have 2 compounds, 4 elements at least between it all, and then usually the front 2 just switch places. Okay. Then we have single replacement, where we start with where we have one thing that's replaced. We have usually 3. We have 2 parts and 3 elements, and usually the one that's all by itself switches with the one that was with a partner. Okay. We have synthesis, which is where we make something by starting with 2 reactants and ending up with 1 product. Okay, and then decomposition, where we break something down, is taking one thing on the reactant side, like one compound, and it breaks up into 2 or more products. Okay? So yeah, hopefully that helps with the types of reactions on your assignment. Just follow through the best you can with the questions. Otherwise, let me know if you have any other questions. All right, chemistry, talk to you later.